All right, this problem says an exponential growth or decay model is given. Here it is right here. The exponential growth or decay model. Now it looks kind of simple, or maybe it looks confusing because what the heck is that little t doing in the top? But of course that's an exponent, and the growth or decay always has to do with a number, the number 1. If I had, exactly, if I had written 1 to the t, will that change anything? If I raise the number 1 to an exponent, what's 1 times 1 times 1? Does it matter how many times you do it? It doesn't matter. But what if it was 0.99 instead of 1? Would that make a difference? What's 0.99 to the 100 power? Is that going to be bigger than 1 or smaller than 1? If you punch it into your calculator, you'll see it's going to be smaller than 1. It's going to be a decimal. It's going to be a decimal smaller than 1. And if I rose 1.01 to the t, yeah, this is going to be a decay equation, and this is going to be a growth equation, because even though it's just 1/100th difference from the number 1 in each case, the fact that you went higher than 1 means that it's like 101% is really what that represents. And this represents 99%, which is a 1% decay, and this is a 1% growth. And the number 1 would have represented 100%, which is just 1. It's just itself, right? So if it was 1 to the t, really you have a 0% growth or decay, which means it's not changing. It's staying the same. So that's kind of, in a nutshell, the idea behind all of this growth and decay stuff. So what does this number represent? What does 0.14 to the t represent? Yeah, that's a decay because it's smaller than 1, right? And if you do 1 minus what equals 0.14, what's the number that you subtracted from 1 to get 0.14? If you do the math there, you'll get 0.86, right? Can you see that? So this is a decay, and find the growth or decay factor. Well, the decay factor, it's an 86% decay factor. This would be a 1% right here over on the right. That would be a 1% growth factor. And this up here, 0.99 would be a 1% decay factor. Let me see if I'm saying that right. I might be getting those two mixed up. Sorry, I mixed that up. This is 86 down here. This is 86% decay rate. Actually, maybe that's not right either. This number is just a 0.14. It's a 0.14 growth or decay factor, and it says find the growth or find the decay rate. The decay rate is going to be 86% decay. Yeah, I think that's how you do it. So let's try another problem. What if this problem had said 1.08 to the t? What would the answer be for that? Yeah, that would be a growth. So I'm going to make that in purple. That would be a growth. And what would the growth factor be? Yeah, it would be 1.08. That would be the factor. And what would the rate be? 8%. It'd be 8% because it's 1.08 is like 108%. So no, I said that wrong. It's 108% is the growth. Sorry, nope, I was right. Originally, I was right. Again, we don't teach this in the high school. We don't teach the words this way in our high school curriculum, so it's a little bit different, a little tricky how they want us to say it. But yeah, it's an 8% growth rate. It's an 8% growth rate. And the factor would be 1.08, because factor means what do you multiply by? So you're multiplying by 1.08. So that's the growth factor, because it's higher than 1. And the rate of growth is 8%. That's how you would do those problems.